Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue our first topic, which is resultant force, with the third learning objective, right? Problem solving question. So there are three examples of question. For first one is about coconut falling from a tree. Okay, figure 1.7 shows a coconut of mass 2.0 kg falling with an acceleration of 9.0 meter per second squared. Okay, sketch the free body diagram of the coconut and then calculate the resultant force acting on the coconut. State the direction of resultant force and what is the magnitude of air resistance acting on the coconut. Okay, given that gravitational acceleration is 9.81 meter per second squared. Alright, for the first question, you want the free body diagram for the coconut. Alright. So for the coconut, we have two forces acting on it, which is weight and air resistance, and both force is in a opposite direction. Okay, because weight is facing downward, following the gravitational acceleration, while air resistance is facing upward because the resistance from the air. Okay, this is what we can see that happened to the acceleration of the coconut. We can see that the acceleration is only at 9.0 meter per second squared, while the gravitational acceleration is 9.81 meter per second squared. Okay, the acceleration is reduced because the air resistance. Alright, for the B, what is the resultant force of the coconut? Alright, given that the mass of the coconut is 2.0 kg and have accelerate at 9.0 meter per second squared. Alright, according to Newton's second motion of law, he said that an object that has exerted external force will be accelerated. Okay, so to find the resultant force, we must UF equal to MA. Alright, so substitute mass for 2.0 kg times the acceleration 9.0 meter per second squared. So we got 18 Newton for the resultant force of the coconut. Alright, and then C, it asks the direction of the coconut. So we know that coconut is accelerate downward, therefore the resultant force is downward. Alright, and D, what is the magnitude of the air resistance? Okay, given the mass of coconut is 2.0 kg, the gravitational acceleration is 9.18 meter per second squared. So we know that the comparison of the force, okay, resultant force is the sum of the two force or more force, alright, to be a single force. Okay, for this situation, we know that the resultant force is weight minus with the air resistance, because we assume the weight is on the positive direction and air resistance is the negative direction. Alright, so weight minus with air resistance. Okay, so we substitute for the F if the resultant force that we got from B, which is 18 Newton, equal to W, weight is the mass of the coconut time with the gravitational acceleration. We got 19.62 Newton minus with R, which is air resistance. So we got R as 1.62 Newton. So this is the magnitude of air resistance that exerted in the coconut, which is reduce the acceleration of the coconut facing downward. Alright, which is only 18 Newton. Okay, for the question number 2, which is about elevator, a person that is standing in the elevator. So a passenger of mass 60 kg is in a lift. So sketch the free body diagram using the symbol W to represent the weight of a passenger and symbol of R for the normal reaction from the floor of the lift. So we know that there are only two forces exerted on the passenger. Alright, and B, calculate the magnitude of the normal reaction when the lift is 1 at stationary, 2 moving upward with acceleration of 1.2 meter per second squared, and third, moving with a uniform velocity of 8.0 meter per second, given gravitational acceleration is 9.81 meter per second squared. Okay, for first all, we know that when the object or the passenger standing in the stationary, we know that resultant force will be 0. Okay, and then when it moving upward with acceleration of 1.2 meter per second squared, we know that the resultant force is not 0 because moving with an acceleration, okay, which is in increasing velocity. Okay, the third one, moving with uniform velocity. When velocity is uniform, we know the acceleration is constant. Okay, when acceleration is constant, resultant force will be 0 because two forces are balanced. Alright, so we go for the first question. Sketch the free body diagram for two forces. Alright, here is normal reaction is facing upward while the weight is facing downward. Right, following the gravitational acceleration. Okay, B, calculate the resultant force when the lift in stationary. So we know that when an object in a stationary, the resultant force will be 0 because both forces in opposite direction are balanced. When balanced, the resultant force will be 0. Alright, so we express in the comparison R equal to W. Normal reaction force is equal to weight force. Alright, so we substitute the information given into the weight, which is mass times gravitational acceleration. So 60 kg times 6.81, we got 588.6 Newton. So this is the same magnitude value of force for weight and normal reaction when the object is in stationary. Okay, question B. What is the resultant force when the lift is moving upward with the acceleration of 1.2 meter per second squared? So from the Newton's second law of motion, we know that resultant force is equal to mass times acceleration for the object. Alright. So to get the resultant force of an moving object, a mass times acceleration, and then for the expression, we can see that F is equal R minus W because the object is moving upward, so the normal reaction force is larger than the weight. Okay, so we assume normal reaction facing upward is in positive direction while weight is in negative direction. So R, normal reaction minus weight, alright, is equal to MA because force is a sum of two forces that to produce a single force, which is a resultant force. Alright, so substitute the value R minus the weight, which is 588.6 Newton, is equal to MA, which is 60 kilo times 1.2 ms negative 2. Right, the acceleration of the lift And then we got R is equal 72 plus 588.6 Newton. And the answer is 660.6 Newton. So this is the force that exerted on normal reaction. Alright. So we can say that this force is larger than weight, which is 588.6 Newton. So the difference for the force is only at 72 Newton. Alright. So we know that this the resultant force is not equal to 0. Right, for the question B3, he asks what is the resultant force when the lift is moving at uniform velocity at 8.1 meter per second. So we know that when an object moving at uniform velocity, the acceleration is 0. Because it is constant, right? So when acceleration is 0, the resultant force also will be 0 because both force that acting on an object is balanced, right? So when balanced, resultant force is 0. Normal reaction is equal to the weight, which is 588.6 Newton. Okay, for question number 3, which is trolley on a pulley. Figure 1.10 shows a trolley of mass 1.2 kilogram being pulled on a table by a load through a pulley. The trolley moves with an acceleration of 4.0 meter per second squared against a friction of 6.0 Newton. So in this situation, we know that the object, which is the trolley, which have mass and acceleration, pulling by a load through a pulley. Alright, so we know that the trolley is moving to the right because it is pulled by the load facing downward through a pulley by a string. Okay, so when the trolley is moved, there are frictional force at 6.0 Newton to the left. Okay, because it is in opposite direction to the motion. Okay, so for the first question, sketch the free body diagram of the trolley and the load. Okay, they ask for two free body diagram. First one is for trolley, and then after that is for the load. Okay, use W for the weight of the trolley. Okay, R for normal reaction on the trolley, FR for the friction, and then T for the tension of the string, B is the weight of the load. Okay, so this question is use a symbol of alphabet B for the weight of the load because there are two weight that must be shown in this diagram. So we need to give a different symbol for the weight. Okay, so for question B, compare the weight of the trolley with normal reaction. C, calculate the resultant force acting on the trolley. D, calculate the tension in the string pulling the trolley. And E, what is the mass of the load? Given gravitational acceleration is 9.81 meter per second squared. Okay. Alright, for the first question, sketch the free body diagram for both trolley and the load. So in here, we got the trolley is facing to the right. The motion is towards to the right. Okay, with the tension of the string force, and then the opposite direction is frictional force to the left. Okay, so the trolley is moving in a horizontal motion. Alright, and then we have normal reaction facing upward is balanced with weight facing downward for the trolley. Alright, for the load, we only have two force, which is the weight of the load facing downward, and then we have the tension of the string facing upward, which is balancing the load. Alright, so for question B, compare the weight of the trolley and the normal reaction of the trolley. So the weight of the trolley is equal to the normal reaction. Alright, why the weight and the normal reaction is equal? Why it is equal even though the trolley is moving in a motion or in a acceleration? Because the trolley is moving in a horizontal motion to the right with the tension of the string, and the frictional force is facing to the left in opposite direction. Okay, so the trolley move in horizontal, not in vertically. So that's why the normal reaction and the weight is balanced and equal. Alright, and then C, what is the resultant force of the trolley? Okay, using the Newton's second law of motion, which is F equal to ma. Okay, F is the resultant force, mass of the trolley, and acceleration of the trolley. Okay, given that mass of the trolley is 1.2 kg times with the acceleration of the trolley 4.0 meter per second squared. So we got the resultant force of the trolley is 4.8 Newton. Alright, so the magnitude of the resultant force is 4.8 Newton. Okay, and then we go to question D. We're asking for the magnitude of the tension in the string. Alright, so we know that tension of the string is facing in the motion of the trolley, which is to the right. So we assume the tension is in positive direction, and then the frictional force is in opposite direction to the left. Okay, so given that resultant force is 4.8 Newton and frictional force is 6.0 Newton, according to resultant force from the sum of two force, which is tension minus frictional force. Why minus? Because we assume tension is moving to the right and assuming it's positive, and frictional force is in opposite direction to the left, so it will be in negative sign. So tension minus frictional force, and then thus we got tension is equal to resultant force plus frictional force. So tension is 4.8 Newton, resultant force plus with frictional force 6.0 Newton. So the tension force in the string is 10.8 Newton. Alright, so we know that when the resultant force is not equal to 0, so we know that one of the force must be larger. Okay, and now we can see that the force in the string, in the tension of the string, is 10.8 Newton, which is more larger than the frictional force, which is only 6.0 Newton. Okay, so we know that the both force is not balanced, and the resultant force is not equal to 0. That's why we got resultant force is 4.8 Newton to the right, following the direction of the larger force. Okay, for question E, you're asking what is the mass of the load. Okay, the load over here, what is the mass of the load? Given the acceleration of the load is 4.0 meter per second squared, and gravitational acceleration g is equal 9.81 meter per second squared. Okay, so acceleration of the load is followed by the acceleration of the trolley, because the load pulling the trolley with the same acceleration. Okay, So resultant force, using the formula, we substitute M times with 4.0 ms negative 2. So we don't know yet about the mass of the load, so we express with the 4m, and then according to the weight of the load is equal to mg. Mass also we don't know yet. Time with the gravitational acceleration, so we express in 9.81 m, which is mass lah. So for the comparison of the force, the resultant force is the sum of two force, okay, which is the weight of the load minus with the tension of the string, okay, because there are only two force acting on the load. Alright, for this first one is the weight of the load, which is facing downward. So we assume that the direction of the weight is positive, and the direction of the tension of the string is negative. So B minus with T. So we substitute for the F is 4m equal to 9.81 m for the weight of the load minus with the tension of the string, which is 0.8 Newton. And then so we calculate, we got m is equal 1.86 kilogram. So this is the mass of the load that pulling the trolley with acceleration of 4.0 meter per second square. Alright, so you may answer this formative practice 1.1, number 1 and number 2, and you can discuss with your teacher. Alright, so that's all. Assalamualaikum warahmatullahi wabarakatuh.